Alright class, now we are rolling. We are using properties today. I have a little chart down here for you. We just learned in our last video what the properties were. We defined a lot of them. Yeah, I know it wasn't too interesting, but if you need a little help, here's some more examples down there in that table. Go ahead and have a look at it if you need to. Pause, maybe write a few down if you want. If not, we are moving on. So let's look at our first problem. Hey, we want to use some properties. Right now, we have talked about combining like terms, but how can we do that and why? Well, our properties explain it. So if we want to look here, we would want to get our like terms together. So if we would do that, we would write 5y minus 3y, and then our other like terms, we had our positive 18, so plus 18, and the positive 4. So we have those. We want to look from this step, our first step, to the second step. Why could we do that? Well, by the commutative property, we are allowed to go ahead and change the order. Again, remember the CO, change the order of things that are happening. If we would want to further try to simplify this, we would take our first two and we would group them. So if we would group them like so, if we are changing the way things are grouped, we put in the blue there, that is called the associative property. If you are ever going to abbreviate the associative property, do not stop. You must go all the way, ASSOC, for obvious reasons. Okay, make sure you abbreviate associative by going assoc. So the associative property there, and then finally we can combine our like terms. So we combine the first two together. 5 minus 3 is 2y, and the last two together are like terms. 18 plus 4 is 22. So that would be our answer there. And this red portion where we combined things, I know we didn't go over it yesterday, but we would say that that is the closure property. It may not necessarily be on your IXLs, but the closure property means that if we are in the real number system, we're going to stay in the real number system. Number two, we have problems that we have done in the past. We can go ahead, we are given A, B, and C over on the right, and we can substitute those numbers in. So we would have 4 times negative 1 plus 9 times our B value is 4. And then minus 2 times our C value is 6. Once we have that, we would want to say that that is the substitution property that we talked about yesterday on our notes. We substitute those in, then we can go ahead and simplify order of operations. So negative 4 plus 36 minus 2 times 6, which is 12. So then we'd go ahead, put them all in there. Order of operations left to right would be 32 minus 12, so we would have an answer of 20. Again, the reason why we can add and subtract things like that is called the closure property. Moving on, now we have a few examples, 3 through 7 here. We want to find what x is and then state what property tells us that we know what that is. Well, 8 plus something needs to equal 8. So 8 plus something needs to equal 8. Well, we know that x would be equal to 0. Why is that? That would be the multiplicative property of 0, or that is incorrect. I am wrong. It is the multiplicative identity. And again, I am sorry, I just messed up. It is actually the additive identity. We are not multiplying. So we would say this is the additive identity. Sorry, getting my things confused there. Even I mess up sometimes. So additive identity, we're going there. Number 4, what would x be? Well, 12 times something to get 12. X would be need to be equal to 1. So that one, this time, now it's right. The multiplicative identity. We started and stopped with the same number, the 12s, and we are multiplying by 1. On number 5, what is x? Well, something plus 0 needs to equal 14. So of course x would be equal to 14. And why would that work? Again, it would be very similar to number 3 up there. It would be the additive identity. And most of you will be able to figure these out on your own without the properties, but having the property helps out. Number 6, what would x be equal to? Well, 6 times 1/6. We could say that 6 over 6, if we reduce that, that is equal to 1. So x equals 1. And how can we know that? Well, that is what we call the multiplicative inverse, or using of reciprocals. 1/6 is the reciprocal of 6. We can write 6 as 6 over 1, and so that flipped would be 1/6. So that is why it is that. And number 7, what would x be here? Well, x would be equal to 4. What is that, or what's the reason why? Well, the commutative property there, because we are changing the order of the 5 and the 4. Number 8, we have a number being multiplied outside of the parentheses. We just want to go over really quick the distributive property. So we already know it's the distributive property. But this time we have a number on the back side. Guess what? It makes absolutely no difference. You still multiply that times both of those. So negative 5 times 4 is negative 20. Negative 5 times negative 8 is a positive 40p. So can't combine like terms. That's our distributive property. Just make sure it's a negative 5 times a positive 4 and a negative 5 times a negative 8, which gives us the positive 40, which is why we have a plus sign down there. Don't forget that. Okay, number 9, and we'll continue on 10 and 11. If you have a problem that starts like on the if statement, it says 32 plus p equals 29, then we want to know what is changed in the then statement. Well, each time you see that it is being multiplied times 6. So we would say that that is the multiplication property of equality. So the multiplication property of equality means that it's being multiplied on both sides of the equal sign, hence the equality portion right there. 10 and 11 are the same. So we have if then. What is changing from the first one to the second one? Well, in number 10, both sides are being divided by 4. So we would say that that is the division property of equality. Because both sides are being divided by 4. Moving on to 11, again we look what is changing from the if statement to the then statement. Well, in this time both of them, there it's being subtracted by 6. So, yep, you guessed it, it's going to be the subtraction property of equality. So the subtraction property of equality. Very good.